Hello. Thank you for having me. Today, I'm going to talk about how Helm, the package manager for Kubernetes, works. I hope you can all see my slides. My name's Matt. I am actually one of the 3 Matts who work on Helm. So if you see a Matt working on Helm, it may not be me. I've been around the space with Kubernetes and other things for a while, and I currently work for Ranger. But you don't really care to hear about me. You're here to hear about Helm, the package manager for Kubernetes. It's a project written in Go that's been around for about 6 years. You can see some of the vitals up on the screen. And it is a CNCF project. That's a Cloud Native Computing Foundation graduated project. And here's a quick history. So Helm was started by a little company called Days, which was a division of Engineard back in 2015. And it turned out to be really popular, well, as popular as something was for Kubernetes back in those early days, right after Kubernetes 1.0 came out, and I think 1.1. And then at the start of 2016, Helm merged with another project called Deployment Manager, which was part of the Kubernetes project, which was at the time still a Google project. And they merged into one under Kubernetes called Helm. And that's when version 2 development began. And then not long after that, Kubernetes joined the CNCF and Helm along with it as a Kubernetes subproject. And then Kubernetes grew, and Helm v2 came out at the end of 2016. And then after that, we saw massive Helm growth. Our usage shot up. We went from package downloads, and we were able to measure them from the thousands to the millions to the tens of millions every month. And things just saw this massive increase in popularity. Then at the end of 2017, we started work on Helm v3, and that's because the architecture under Kubernetes had changed, and we need to change with it, and that was the primary driver for that. Not long after that, in 2018, Helm actually became a CNCF incubation project. It would later become a graduated project. And then at the end of 2019, in November, we launched Helm v3, which is the current version of Helm that I'm going to talk about today. When you think about, this is a model that I have for thinking about package managers, right? You've got an operating system on the bottom, and on top of that, you're going to have your binaries and configuration, and you're going to have a package manager that can install those. And I think of something like Postgres installing binaries and configuration and things like that. And then you've got a configuration manager sometimes above those to do things. If I'm in the Linux world, it might look like I've got GNU Linux on the bottom, and I've got Elf binaries and configuration in my etc directory, and then Zipper, apt, yum, something like that can install things. And above those, maybe Chef, Puppet, Ansible, a configuration manager that's doing something that will use a package manager that can install things and manage them, right? That's how I look at that sort of stack. And now if I'm going to relate this to the Kubernetes space and the Helm space, this is what I would have. I'd have Kubernetes on the bottom. Then above that, you've got container images and the Kubernetes manifests. And Helm as a package manager lets you install those images and manifests and run them in a Kubernetes cluster. And how it works as a package manager. When you need configuration management, you'll have something above it, such as Helm file or the Flux Helm operator. And there's many other tools that sit in that configuration management space, depending on what you want to do. And many of them can take advantage of Helm to install those things and run workloads inside of Kubernetes. And so this is kind of where it sits in that stack. And so I can't go without talking about Kubernetes. And Kubernetes is another project in Go. It's a CNCF project. And just in case folks aren't all that familiar, I'm going to do just a quick crash course in a couple of concepts that will play into Helm here. So if I take something like the Kubernetes API, and it's got a bunch of nodes that it's managing to run workloads on, and I want to have 3 instances of a container or something, I may have a deployment, and I will just tell Kubernetes I want to run it by giving it the manifest. And then it will see that I need this, and the controllers will spin up instances of my workload on different nodes in the cluster. Now, if a node goes down for some reason, maybe the hardware went out in it, or it got pulled out of circulation, or there was something else going on, maybe even my application crashed, Kubernetes will then see that an instance went down, there aren't enough there, and it will remediate it because it's a declarative system. You declare what you want, and then Kubernetes tries to continually make that situation happen. It'll go ahead and create a new instance and get that up and running in order for things to work. And all of this, all these Kubernetes things are organized in a multi-tenant way using namespaces. And you can have one user have access to more than one namespace, maybe you only have one. In larger companies and organizations, they lock things down a lot to namespaces, and just cluster administrators have access to the whole cluster. And quite often, you just want to run your workloads in a namespace, and they may have quotas and other details put on them to constrain what somebody can do, the same way you might have with another platform. And of course, the Kubernetes API is complicated, right? 684 pages in printed form. Somebody took the Kubernetes API reference and open API form, not details on how you would use this or what you want to do with it, just the details. And they turned it into a book at 684 pages of open API specifications. If you're going to run workloads in a Kubernetes cluster, you could use about 2/3 to 3/4 of that material. And that's really a lot of material that you could end up using in order to get something done. And so let's take WordPress as an example. WordPress is that perennial example. And so I do like to use it because it relates to folks. And so if I'm going to go run WordPress in a Kubernetes cluster, I'm probably going to run a deployment so I can run the WordPress PHP application and have it be up and running in a resilient way because that's stateless. But then there's my database, right? I'll probably have MySQL, Maria, Percona, something like that, running in a MySQL compliant database. And that's going to run. So I'll run that as a stateful set. Because stateful sets are the Kubernetes objects that can deal with applications that require state. It knows how to do volume handling and those kinds of things. Now I need to expose my stateful set to my WordPress. So I'm going to need a service for that. I'm going to need to be able to expose my WordPress out to the world. So I need a service for that. And then I need to share credentials on my database. So I'll use secrets for that. And if I'm going to get any traffic, I need it to scale. So I need a horizontal pod autoscaler for that. And then, of course, I want to expose my WordPress outside of the cluster for people to use that. So I'll use something like an ingress. And so you see there's all these resources that you end up needing just to run something that is actually a fairly simple application in WordPress with a database. It's not really complicated in the grand scheme of different things you could run. And just to run WordPress in a production-ish manner, you're probably talking 500 lines of YAML with a fair amount of repeat yourself in there. And some of these things are going to be nested in there 5, 6, 7 layers deep. So this is where something like Helm comes in. In Helm, you have packages, they're called charts. And the idea is you take your application business logic and your Kubernetes knowledge, and you turn it into a package, a chart. So that way somebody who uses Helm can then go install and use and upgrade and all of those things without having to know all of that Kubernetes knowledge and all of that application business logic. So me, without maybe needing to know a ton about Postgres and stateful sets, can then go leverage Postgres and run it in my cluster without having to have all that knowledge. And Helm will take a chart where somebody else already created all that stuff, and then it'll go install it into a cluster. So then you're running Postgres. And in Helm, we've actually taken the time to look at who are our roles, and we've prioritized them. And so here you can see the different roles with the application operator being at the top and the Helm developer being at the bottom. The Helm developer, those of us who work on Helm, who have to maintain it and build features, we're putting ourselves last and even supporting tool developers just before us. So we can really target how do we make those application operators who are going to go run something in a cluster and those people who want to distribute charts as kind of primary people in that picture. So what's in a chart? Because I think this is really important here. This is the basic directory structure of a chart as it's laid out on a file system. So think of this as a directory, and these are the files and subdirectories in it. You've got an ignore file because you may want to ignore things when you're packaging them up to pass them around, and I'll talk a little bit more about that in a minute. You've got a chart YAML. Yes, it is a capital C, and a lock file for dependencies. I'll explore the YAML file in a minute. A charts directory. So in Helm, we vendor dependencies. So your direct dependencies, you always vendor, and their dependencies are vendored. So when you get a chart as an archive that gets passed around, you actually have all of the dependencies in it in case you want to go install it or do those things. Then there's things like templates. So because Helm is very document heavy, or Kubernetes is very document heavy, we use templates to generate those documents. And then the values YAML, the last one there, is important because this provides your default configuration for your chart. So let's look. A chart YAML is pretty simple, right? The basic form tells you the API version for it, your name, your description. It gives you a version and an application version, an app version. That's because the version of your chart may iterate differently from your application. You could have one version of your application, and then as you're working on improving your chart, adding features to it, you could iterate that. And the versions are semantic version, but your app version, because it's the version of your application, can follow whatever versioning scheme you need. But other information can be in there, such as dependencies. Here we say the name of a dependency, the repository, which I'll touch on in a minute, and its version. And here we're using versions. If you're familiar with NPM, it's a similar style to being able to specify your versions, to say, you know, give me updated patch releases or the newest one within a major, and Helm can go ahead and do that dependency management for you. All of the specific versions are then captured in the log file. I can also capture metadata that other tools can use, maintainers and things like that. Helm doesn't necessarily use this out of the box, though. So let's talk templates, because templates are what are in Helm templates directory. And here you've got a template that you would look in. It's basically the YAML file with template stuff inside. If you've done templates before, it shouldn't be anything too interesting. You'll see a couple of functions in there, like nindent, which is indent with a new line. And there's a whole bunch of functions, but otherwise it's templatizing Kubernetes YAML. And the engine we use is the Go template library that's part of the Go standard library. And we chose this because very early on in Helm's development, we were doing its Go development, and there weren't a lot of other template engines available at the time. And so this was the one that was stable, secure. They did security updates for it, and it was ready to go. And so it was picked up to get off and running. And over time, we've talked about bringing other ones in, but everyone's been happy enough with this that we haven't looked at adding an additional system if people wanted it, because nobody's wanted to contribute it. And there's a ton of functions. In the Helm documentation, there's a function list with hundreds of different functions, from dictionaries to file path lists. There's math work, date transforms, cryptography stuff. There's template functions for all kinds of things that you'd want to do beyond what's in the Go standard library for people who want to get into that. Now, there are some special things that you can do with templates, and one is you can create helper functions. And helper functions, you just create a bunch of, they're basically defined templates that you can call, and you put them in a special file that just starts with an underscore, and Helm knows not to render those out to send them to Kubernetes. There's also a special one, a notes text file, and this is displayed when you install or upgrade something. Helm will take a notes text template, and it'll go ahead and put it up to the screen so somebody who installed it can see some notes on here's what you need to do next. Then we get to the values YAML file. And this file here contains your default configuration. Now, inside your templates, if I refer to .values.replica count, it would give me the value of 1, or .values.image.repository, it would tell me nginx. There are ways to refer to this, and this is the default values, and it's free-form YAML where there are certain styles that we recommend, but it's free-form for the package author to create as they need or feel fit, and then they can document it. Now, these charts can be transmitted and shared or kept and used in 3 different ways, and I'm going to walk through each of these 3 real quick. First is on your file system. If you point Helm and its commands at a directory that contains your stuff, Helm will read it and know what to do with it. So I could tell it to install this thing and just point it at this directory, and it would know how to find it, discover it, and install it. Now, that's not very shareable with everybody else. If you're going to iterate on things over time and roll back and get to other versions, it's not the best way, but it is a way that Helm does work. The second is the Helm Registry. And if you're familiar with other registries, maybe Debian packages and things like this may look a little familiar. Here we have different charts in their different versions packaged up as tarballs. And Helm will actually create these packages for you, and it can create the index.yaml file, which is that listing of here's the charts and their packages and things like that. We'll look at one in a minute. But it's that thing that Helm can look at and then find its different archives for the different versions. And this is the traditional way Helm registries have worked and what Helm has long worked with, and it's held off the model of what many others do. And so Helm will download that index and read it. It can be used for searching and other things as well. And Helm can create it. I know JFrog, I think Artifactory does it. We have another project called Chart Museum. There's many projects that can create these index files and let you work with archives in them outside of Helm itself, which is often just used in a flat file system. This is a quick look inside of an index.yaml file. You have an API version for the index entries, and then under entries, you have your different charts. And then it's basically a YAML list of the different versions of that chart with some metadata. And much of this metadata comes from the chart YAML, but some of it doesn't. Like the URLs will tell you, well, here's where the archive for it is for a tool to download it and do something with it. And here's the digest from it. And if it doesn't tell you, it's the SHA-512 of the archive file. So certain verifications and things like that can be done. And so it's a pretty simple structure, and then Helm knows how to read that. And other tools can be built to read it as well. Then there's OCI Registries. And OCI Registries, the container initiative, it originally was just for container images, but they've expanded to have other things in their distribution spec. And so if you go look at the distribution spec today in the 1.0 release form, you can store other stuff in there, what they call artifacts. And so Helm charts is a type of artifact that can be put in there. It's currently an experiment in Helm, and search and some other features don't work because OCI registries don't actually have a search API to work with this stuff. But it is a place where you can store it. And we're working to move this from experiment into production. We're kind of conservative in how we do that and making sure all the I's are dotted and T's are crossed first. And we're trying to do that right now. But it is currently an experiment that you have to opt into. So let's take a look at the Helm CLI, right? If I want to go ahead and, I'm running low on time. All right, so if you want to go add something here, this is a simple way to add a repository, and it should look similar to things like that you're used to. And then once you've added a repository, you can install something from that repository, and you'll see release name, the chart to install, and you'll see the notes at the bottom there. And so what Helm ends up doing here is takes that chart and installs the manifest into a cluster in a namespace, and it also creates a release secret. So it knows how to upgrade, roll back, do things like that. And so because that secret's in there, you can do Helm LS or Helm list and see what in that namespace has been installed and what revision of it is installed there with some other details. You can also, as I talked about the default configuration earlier, you can go ahead and set some other values. Here's an example of setting one of those values at the command line. You can use set more than once to upgrade, or you can use this on install as well to override the default configuration. But the other way you can do it, because using it at a command line isn't always the best way, is you can have a custom YAML file with your custom configuration, and it's just used as an override to the default configuration, and you can actually pass that in on upgrading or install as well when you're doing this stuff. Now, there are a number of other commands here that I'm not going to cover, from templating to statuses to showing the details of packages. There's a lot more to Helm if you want to explore it. Now, just going to touch real briefly on the Helm architecture here. The Helm client actually has a client package inside of it that calls to a Helm SDK. And that SDK has different packages in it that Helm uses, but others can use as well, including things like a Kubernetes API. And the reason we did that was the Kubernetes packages themselves don't follow semantic version, and they're always breaking changes. And so we created a wrapper around it so the rest of Helm is stable. But if you're going to build something, you could use the SDK as well. And if you want to find charts, the place to find them is Artifact Hub. It's another CNCF project. It's the way we deal with charts being distributed all over, having one central place to find things. And you can search for Helm projects and other things on there, and it'll tell you all kinds of rich information about them. These are some of the things that I did not cover in this really brief talk. There's plugins, library charts, all kinds of testing and linting. There's hooks where you can hook into different parts of the process and cause custom things to happen, such as when you're upgrading, then having some custom thing to happen in the cluster because an upgrade just occurred, like updating your database schema or something. And of course, there's signing and provenance because you need security in these things. Helm does have built-in signing and provenance. And thank you for coming and listening to me yammer on. If you've got any questions about Helm, you can hit me up online, or there's a book, Learning Helm, that some of us Helm maintainers wrote. You can go check it out.
Thank you very much. So we're coming close on time, so we'll just have a few questions. Are there any questions out in the room? All people are typing. You said that you're kind of wrapping Kubernetes, which constantly keeps breaking things, so that Helm is stable. What is that process like to guarantee that kind of stability on an otherwise unstable base?
So the Kubernetes packages that they use to interact with their API in the Go language don't follow semantic versioning, and they've long broken. And it used to take us weeks sometimes when they made a change to upgrade and test everything. And so we created a wrapper package so we didn't have to upgrade everything throughout the code base. It just executes our functions, and then we just update those individual functions, and it's a smaller surface area. And what used to take us, maybe a couple of weeks to do, normally can be done in about a day. And so it's been a huge benefit. This is not their REST API, but their Go API that we have to deal with. And that's because Kubernetes itself doesn't follow semantic versioning, and they're not worried about breaking packages at any time.
Awesome. So there's a question from the room. Fantastic talk. I wonder if you can talk a bit about the relationship between OCI and Helm, and how Helm positions OCI in its own ecosystem.
We're not doing a lot now. The OCI, as far as artifacts, is just now really starting to take off. It took them a couple of years to go from it being an idea to it being a release in the specification. And we started our experimental work along the way and kind of encouraged it. And now they've released the specification, and now we're trying to build up the layers there because we're conservative. So they're supporting libraries and packages. We're trying to help get into a stable shape. Then we'll release our work because we know we've got a solid foundation that it's built on. But it has some limitations. There's no search functionality. People like to use commands like Helm search and be able to search their repositories. You can't do that with an OCI registry because there is no OCI search API on a registry. And so there are some limitations to that. And we know a lot of people are going to use this because then you just need one place to store all your bits. And you can store lots of things in that registry and transport that registry around if you're going to do offline, or if you as an organization are going to run your own. It's nice to just have one tool. And so we're very supportive of it, but we're just now getting it into good shape because stability is a big thing for us.
All right, let's see if there's any more questions in the room. Last call. Going once, going twice.
Oh, I see one real quick. How does Helm handle new containers that appear in a registry? Or maybe. So I can say with Helm, in the chart, you're going to tell it the default container to use and probably make that overwritable. And so when new containers show up in a registry, it takes somebody specifying through configuration, use another tag, look at this other container in a registry. Helm just doesn't grab any old container because you want to have the appropriate Kubernetes configuration for that workload, right? It's not just about running a container, but how should it be run? Are you passing configuration into that container? Like in my example, I used the blog title as something that you could pass in. You can actually pass in application logic. So you want to know that information and couple them together, which a chart does. And so new container images in a registry don't mean much to us until they actually are used by a chart.